Good day to you. This is Anagalactic on the third day of December, and everything is well here in Chico, California, so we can go on with our promised presentation on the collapse of the wave function. I have given at least two presentations of the collapse of the wave function. What is the wave function? The Dirac equation is a computation of the so-called wave function. So is the Schrödinger equation. Erwin Schrödinger. Heisenberg came up with an early formulation. It was a matrix formulation. How is that different from the wave equation? It's the machination that occurs between two events. These are not strictly speaking positions, although position obviously is involved. It's the transition of state, generally of an electron, but it can be of a photon. There is a version of the quantum paradox which applies to the proton as well. You don't hear about that as often. But those are the three primary particles. The proton is a space particle. Just accept that for now. I have proved that. It's extremely profound. Most of my discoveries are extraordinarily profound, which should put you on your guard, because that's how a nutball talks. Okay? There's a very fine line between a mad scientist and just a madman. Because you're going off into the cloud to try to divine universal understanding in some application. In this case, the transition of state. And we'll talk about the electron first, but what we want is the collapse of the wave function for the photon. And that has to do with the flight of the photon. The photon has four distinct states. We use the word state to describe what is at a position. In other words, whatever is at that position has some characteristic. We generally divide that, or traditionally have divided that, into matter or energy. But there's also space, and there's something called time, which you may have heard of. You're experiencing it right now, right now, right now. Oh yeah, be here now. You can't help it. You'll drive yourself nuts if you try to be here now. You know why? You can't catch up with now, because it's always moving. That's the characteristic of energy. Of course, it has to exist in space. Does it? Does it indeed? Does energy exist in space? Now, when you're facing reality, as we call it, you have to say that it exists in space. Why? Because everything we perceive is in space. But there is an aspect to spatiality which we cannot perceive, and that is called motion. That can be boiled down to angular momentum. So the angular momentum is a state of the electron. What about the proton? Does that have angular momentum? That has not been determined, although a man named Gell-Mann. Now we have two particles, right? The space particle and the angular momentum particle. The space particle represents centripetal force, and it is a force no matter what Dr. Sabina Hassenfelder says. We have a space particle that is centripetal force pulling in spherically to a core. That's where space goes. It's being pulled into a center. Changing the characteristic of space around it is pulling it in. The electron exhibits centrifugal force. It's trying to go out. So the proton is pulling space in, but the electron is generating angular momentum, which is the definition of centrifugal force. So the proton is the space particle for pulling in space, and the electron is the centrifugal particle for pushing out energy. And those two forces balance the entire universe. That was essentially proved by Ruđer Josip Bošković in his two-force mechanical system, which will come to dominate science, although it looks like we're running out of time and science will never catch up. You can catch up, though. Science only applies to a single human being at a time. If it applies to a group, it's no longer science, it's a Vatican. And you cannot believe the church any more than you can believe the Congress. Okay? That's what science is. You learn directly from the universe. Now, I am not directly the universe. No scientist is. No human is. What we do is we attempt to rationalize what we see. That is what we measure. How we measure things is an issue I've gone into in extraordinary detail since I discovered a new way of measuring things. That's also extremely profound, and now you've got to put up a red flag. This guy's a crackpot. That's science. That's what you have to do. You have to question anything anyone says, no matter what it is. Can you prove it? Now, that would get tedious if we had to prove everything. In fact, it would be an infinite regression, what's called a recursion. It's simply a form of circular argument that just spirals away. You never reach your origin or your destination because you're locked in a circular argument. We have that problem defining infinity. And that's what we're going to get into today. Centrifugal, centripetal, those are the two forces. There's space and there's energy. Space is not perpendicular with time, although in the derivative formulation executed by Albert Einstein using hypercubic space, he was able to show that in the derivative form of energy, which is time, that is perpendicular to the derivative formulation of space, which is linear systematic space. And hypercubic isn't fooling anybody. It is straight lines. It's a grid. It's extrinsic geometry. That doesn't work. When you're trying to understand the intrinsic geometry of the universe, you cannot apply a grid. You have to apply something else. It will turn out to be a spherical grid. In the atomic system, we see force shells. Those are spheres. And there are 7 of them. You can look that up in Wikipedia. It might be 8. The problem in deciding how many shells are the maximum number of shells in an atom has to do with the nature of the distribution of the atomic shell system around the protonic core. But the protonic core cannot hold much more than 100 protons. They bind together up to 100. 92 is uranium. So I think you understand those have a certain characteristic. Uranium, plutonium, neptunium, yeah. There are some higher order atoms in the periodic table, but they're highly unstable. Some of them only last under a second before they disintegrate by essentially spontaneous fission. So, we have an atomic structure that shows us that the universe from the inside out is spherical. We have also determined that the edge of the universe must be spherical. That has been argued, ineffectively so. The so-called saddle shape, the negative curvature, which is the hyperboloid system, that does not apply to the universe. There's no such thing as hyperbolic space, although that is a derivative space of spherical space. So that's what we're going to be talking about soon. I've been promising that, but I've also promised at least 3 times to recapitulate the collapse of the wave function. Now, the collapse of the wave function does not apply to the proton. It does apply to the electron, but only in a specific sense. You may have heard of entanglement. Don't worry about entanglement. It's actually coordination. It shouldn't be called entanglement. But the nature of entanglement is basically the same as the nature of the collapse of the wave function. So we began by talking about the wave function. What is that? Nobody knows what that is. That is the quantum paradox. You have men like Tim Maudlin, an excellent presenter of physics. He's a pundit. He is a authority figure, he thinks. And he is seeking to defend the established order of wave mechanics against the incursions of such unbelievers, such heretics, as Dr. Bernardo Kastrup. And I've checked Dr. Bernardo Kastrup's work. He certainly has more on the ball than Tim Maudlin. Unfortunately, Bernardo Kastrup is a coward, and he can't face a pedant like Tim Maudlin. He proved that on the Kirchheim-Mungall show. You can look that up. I've given several presentations on that because I consider it to be a landmark in the modern history of physical science in its current psychotic state. So part of the psychosis is that nobody can figure out the collapse of the wave function. So what is the paradox there? First, you have to know what the wave function is. It is unknown what it is. Nobody knows what it is. Dr. Bernardo Kastrup says that's because it's not real. Tim Maudlin says you're out of your mind. Of course it's real. Neither one of those men is correct. And they should have started out that way, and this is kind of a indirect slight against Kirchheim-Mungall, who is a beginner. He's extremely good. He has a natural aptitude, but he is young, and he's being pulled into the dark side of the Force. Just thought I'd throw that in. I love Kurt. I have very high hopes for Kurt. But the highest hope I have for Kirchheim-Mungall is he's going to interview me, or he's going to stay a declining Jedi who's going to end up working for Darth Vader. So the collapse of the wave function is an unknown situation. It's a phenomenon that just gets everyone staring at it and then guessing. So the Dirac equation is a guess. The Schrödinger equation is a guess, and it doesn't make sense, and Albert Einstein pointed that out, and no matter what Stockholm said in 2022 in October about the nature of the quantum paradox, that it has been figured out, no it hasn't, but I figured it out. So how does this work? We're going to talk about the photon, which has 4 states, 4 known states. In one of the states of the photon, it's an electron. Okay? So what's the essential difference between the electron and the photon? I think you know that the electron has an angular momentum value that's locked centripetally to itself, and nobody has ever figured out how energy remains locked in one position which can't even be measured. But it's there because electrons can be fired from a gun. Okay? So electrons are a kind of particle related to the proton, obviously. Well, they're spherically related to the proton. The atom proves that. That's one state of the photon, is when it's an electron. Now, the electron can emit photons in what are thought to be quantized particles. And that would be the emission state. That's what can't be measured. And then a photon is also absorbed. So it has an electronic state where it's locked into an electron. It's released, that's a second state, and then it flies. What it's doing, that's a photon. And it is a particle, and I'll show you that. But it's a very strange particle. And if we had a brain in our physical science heads, we would be concentrating on the photon to explain its flight. Because it travels at a certain speed which is considered to be constant. Dr. Alexander Unziker has strongly questioned that statement, but he'll never figure it out himself. So Dr. Unziker is also heading down a blind alley. All physicists are, and they don't know how to get out of the labyrinth. You need to start with the fundamental particle of the universe. That's either a proton, or an electron, or a photon. Those are the only particles. The electron and proton form the atom, so those are critical to understand. That is their relationship. I got it. So I have that for you. But we want to talk about the third particle that has 4 states: electronic, emission, absorption, and free flight. It's the free flight particle that baffles the you-know-what out of us because it doesn't have a position. You could say that it has an origin, it has a frame of reference. That would be its emission state. When it detached, how did that photon detach? That's part of the wave equation. That's what the wave equation is meant to address. The mysterious quantized transition of energy to a free flight mode. And then it travels out spherically. Christian Huygens proved that back in the 17th century, and that is perfectly accepted. It's called the spherical wavefront, and you'll find a lot of malarkey about planar wavefronts, spherical wavefronts. There are other kinds of wavefronts. And none of it is fully understood, but in optics, they understand it well enough to put it to use. That's the whole purpose of mathematics, and ultimately geometry, the basis of science, is to get explanations, we think, in order to exploit nature. Well, that works. So that's a tremendous blessing to the earth, is that we're able to use mathematics and geometry in order to improve our living conditions on earth. Then you would have to ask, what for? I've given presentations on the purpose of science, goes well beyond technology. If you think that the purpose of science is technology, you are lying by not telling the whole truth. No, that is not the purpose of science. Okay, so that's the bracketing framework for the solution to the collapse of the wave function. We want to change that term. It's not a collapse, and it's not a wave. It's not a wave, and it doesn't collapse. Now, I need to prove that. But it's very important to be forthright in science. This isn't a Ouija board. Okay? You have to prove what you say. So, the photon, as a particle, is actually a surface. So it's a surface of energy traveling through space. The way we perceive it, that's what it does. The way we prove this to ourselves is taking a distance measurement on a cosmic scale object. Beginning approximately at the galactic level, the universe is made of galaxies statistically, although there are other objects besides galaxies, obviously. A galaxy is made of stars, so you could say that the star is the primary source of luminosity, that is light. The detachment of photons from a system of atoms in a star, ions, atoms in a star, are continuously giving off light by a process which is fairly well understood, which I find amazing, since you can't take a star into a laboratory. And yet we know an enormous amount of very helpful information about the production of light from stars. So if you had a quiz, which you should always give the answer to the quiz if you're going to give a quiz, so I will give you the answer, but I want you to think first. Are there any other sources of light besides a star? Well, a Bunsen burner, a candle, a match, those are sources of light. But you actually have to make that happen, right? Well, there are volcanoes. They give off light from lava, infrared mostly. So you could say light comes from a lot of sources. Well, at the cosmic scale, planets are generally conceded to not emit light. You would have to qualify that because they actually do emit light. But not the way a star does. So the star is considered to be the primary source of light in the universe. Are there any others? If you know, you might be excited to give the answer. If you don't know, you may be frustrated, and so it's up to me now to tell you the answer. It's a quasar. A quasar. You can look that up and see the long, enormous history behind that name. It really got its name, I think, in the 1960s. A Japanese physicist gave it that name, suggested it, and it caught on. Its quasi-stellar object, QSO, those are some of the early names for this strange ultra-luminous object. It is the beginning of a galaxy. That is not accepted by astrophysics. Astrophysics is still in the dark age. Our conception of the supermassive black hole proves that our mathematics is out of control. Our mathematicians are psychotic, literally stark staring mad. They're mad scientists because they're frustrated. They're authorities, they're supposed to know, so they make something up. That's the way science has always been. It's called a theory. But unfortunately, for the way humans work together, that becomes a Vatican. And then you're not allowed to say anything else. Just as with natural selection, as I keep harping on for very good reason. I hope you're catching on. Standard model of particle physics is another psychotic theory that begins with an absolute contradictory axiomatic basis that everything in the universe is a particle. That's ass backwards. Ass backwards. So the unified field theory, which Einstein was working on, to his dying day has never been solved, and so the Vatican makes up a superstitious bylaw that you're forced to comply with. So of course the universe is expanding, and it's made of particles, and the black hole sucks light in and sucks the whole universe in. They're out of their fucking minds. And the Big Bang is simply the final stage of psychosis. You know the beginning of the universe. No, you don't. And you won't for thousands of years, if ever. It may not be possible to get that. But of course, the Vatican, since they're the authorities, just make things up. Now, we have photons just flying through the universe. What are they? They're expanding spheres. A photon is an expanding sphere. You have to invert your perspective just a little bit to see that more accurately. It's falling. It's falling to its natural destination because it's pure centrifugal force. So when it's released, it starts falling to the edge, and it continues to fall forever. And we can't handle that. That's not something we can rationalize. I rationalized it. But in order to get that very elusive concept of infinity rationalized, you begin with the photon. The primary particle, from a certain perspective, is light. Light comes in particle form. If you accept that, which you should hypothetically with me in order to follow my proof now, once you have a hypothesis, you have to prove it. If you can't prove it, it's relegated to the trash heap called theory. Theory is garbage. We can't use theory. What we use theory for, it does have a purpose. It's to guide you in the right direction. That this theory may be better than this theory to get the answer. Without the answer, science is crushed. You have to have the solution or you have nothing. Okay? So you have to prove it. Now, what happens when we measure a distance to a star or a galaxy? We'll say galaxy, because we're talking about deep space outside of our own star system, which is, of course, a galaxy itself. We can see outside of our galaxy, as you know, and we can measure distances to galaxies. Okay. The way we do that is by pointing a telescope at the source of light. And the photons from that source of light know where you are. They come right toward your telescope on a straight line. You may question that, you should, but I'm just telling you what we already know. Do we already know that? How likely is it for a photon to go in a straight line over millions of light years, which is quite a few meters, for that little photon to go on a beeline? That is the definition of impossible. It is impossible for that to happen. But if it's a spherical, we call it a wave, but that's the intrinsic aspect, is that it travels, we say, as a wave. We're pretty comfortable with that, and so we call it a solution for that, a wave equation. That's too complicated. You have to simplify that. The photon goes on a straight line from the source to your telescope, and that is strictly impossible. So our physics is inaccurate in measuring the distance to a galaxy. Now we think that it's accurate, and we think that we can prove that it's accurate. I agree. But that produces the most difficult paradox ever faced by science. Because that, strictly speaking, cannot happen. The way you can visualize that it must happen is if you have an expanding sphere, you have an expanding radius, right? So when that sphere goes out, it has to collide with you, correct? So that's the solution to that part of the paradox. That sphere must intersect with your telescope, right? It takes time for that sphere to propagate. In that time that it takes, everything is moving. So it's been discerned, at least by Albert Einstein, and we think we've caught on, that it's not just traveling through space. The photon is traveling through time. Sir Roger Penrose has stated, and I love this statement because it provokes thought, that the photon does not experience time. That's a profound statement, and we're going to concentrate on that. With an expanding sphere, this is a particle that's falling to the edge. That proves that the universe is spherical. Otherwise, it wouldn't go to a spherical edge, and there would be no guarantee that that light would ever reach you. Okay? Now, there is such a thing, we think again, as gravitational lensing, which does change the course of light through space-time, right? Maybe. But that is one aspect of the paradox. It doesn't just travel through space. It travels through another domain that's not space. That is the answer. So now we need to prove it. I hypothetically have stated that the reason the photon must reach your telescope is that it is falling toward the edge on a spherical surface. That's an energy surface, and it has pressure. Okay? So it is a force. It's centrifugal force. The universe is rotating. It's rotating in another dimension. Okay? So while it's rotating, we don't see it because there's no center. And if there's no center, there's no edge. And if there's no edge, there's no center. That's the universe as we perceive it. It's two domains, though. Albert Einstein broke the ground on this. It's two domains. We can only see one of them. We can only see space. We cannot see the energy domain. That forces us to take measurements from event to event, because that is the nature of time, is that when you take a measurement on a particle, you can then take another measurement on that particle. And that means that it might have changed in the interim, in the temporal interim. Let's talk for a moment about entanglement, which is the wrong word. It's coordination. When two particles are coordinated. This can be done with essentially with magnetism. And it forces the orientation of the state to assume a certain eigenstate. If you wait, you can then measure the particle again, and it will have the same state if nothing happens to the particle. But now if you take two particles and coordinate them, they now have the same magnetic orientation, and now you separate them in space. Now, you know the state because you coordinated the two particles into a coordinated state. And then you separate them. It's very difficult to do, by the way. It took decades to perfect, to any degree, reasonable degree, how to measure this. Because what you want to do now is measure one of the particles, which will change its state. Possibly. But you make the measurement in such a way that it does change the state. And once you've done that, you very quickly measure the other particle to see if it changed state in a coordinated manner. And then you check the two measurements. You take a measurement on this particle, and you very quickly take a measurement on this particle to see if it changed state faster than the speed of light. That's not easy to do, but it has been done to a high degree of precision. And it shows that the two coordinated particles change state without any lapse of time. That they do change state simultaneously, which is generally conceded in relativity to be impossible. Well, obviously it's not. It's not exactly obvious. It took a hell of a long time to make this measurement, but that was the reason for giving the Nobel Prize, and it wasn't the first time that a Nobel Prize in physics was awarded for having gone further in making this very difficult measurement. So Zeilinger and two other men shared the Nobel Prize in October of 2022. I gave a couple of presentations on that. It's kind of a sham, but science is in a bind. So here we are, looking at a particle that's falling to the edge of the universe as a spherical surface of energy. And so it must collide with your telescope. When it does, that is the collapse of the wave function. It's simply, well, you can't really say it's simply, but we're trying to simplify this. The wave is a thing, but it has a huge radius. So what is considered to be baffling to us is that when this giant particle, it has a huge radius of its pure energy, and when it contacts your telescope, it's absorbed into an electron system. That's what happens to light. It's absorbed. Light has energy, and so there's an increase in energy in the system, in your telescope. It's interesting to think about how that's transferred to a visual picture that we then look at. But that is the nature of the absorption of light. One of its four states. So this is a timeless moment. A timeless moment in which this enormous sphere with a radius of millions of light years, for galaxies that we have gotten the distance on a straight line to that galaxy, we can see it. And that means that those spherical photons get to the telescope and the entire sphere collapses. That violates relativity, obviously, because it simply can't do that. It's violating light speed. Is it? All right, let's take a look at that. What is happening is obviously centrifugal force. That's important. I'm going to put this on pause because the mowers are coming through. I think you can hear that. I'm sorry about that. This is quite a noisy town, really. Trains. We'll be right back. This will be on pause. Stay tuned. Okay, we still have the mowers kind of hovering around. And so I thought a little interlude might help us get through this time, a bit of background noise. Here we have the space team. This is the orchestra. You'll see Flute Skywalker. I gave him the name Puke Flypaper, which I thought was pretty good. But this is much better because it's organized into a good joke. This is the Space Wars Orchestra. Flute Skywalker. There's a wonderful, gentle warrior. And there you have Harp Vader. Now I called him Barf Paper, I think. But again, Harp Vader is coordinated. Now we have Oboe-Wan Kenobi, played by the immortal Alec Guinness, who really despised his cheap-ass role. He thought that his career was kind of tarnished with that. The viewing audience, including myself, disagrees. No, Obi-Wan, you are the heart of the movie. They should never have let you be killed so quickly. But it makes for a good story, I guess, for 10-year-olds. And then you have Horn Solo. Horn Solo? Yeah. Horny Solo. Horny Solo. He was after the princess. I think he got her at the end, didn't he? Oh, yeah. Space coitus is, weightless copulation has got to be kind of nice, especially if you're taught by aliens to do it right. So have a nice 100-year-long O. Well, I'll bet Horn Solo has enough O's in his name. All right. So that's enough levity. Back to business. I think you still hear it. Well, I'm sorry about that. Can't control the mowers or blowers or the train or the sirens. It's modern age. So we do have a pretty good idea now that we're looking at a sphere. Correct? That is ultimately true. There is a side view of a sphere. That's all we can see of a sphere is a circle. That's actually profound. I used this in my prior presentations this week in order to show the difference between linear geometry and circular geometry, which are quite distinct. Although there must be a relation because only the linear numbers have the computable numbers embedded in them. They're the dyadic fractions, and all the numbers used by the universe are powers of 2, which does go negative. When you go into negative power, you're talking about less than unity fractions. In the multiplicative system, the number 1 is the center. And you see that this is the omega circle, which has a circumference of 1, which means that it is translatable directly on a calculus conversion. There's no avoiding the calculus, but this is the one and only correct place to use the calculus, because it's the only translator between two-dimensional systems. The linear number system is, of course, where we must begin and end, because those are indeed the computable numbers. Now, as I just stated, only the dyadic fractions are computable, because they're the only numbers that are representable in binary form. We have a great deal of information now, very useful information about the machine logic system of our computers, that is binary, and therefore the number 1 over 2 is a representable number because the number in the denominator is a power of 2, and 2 to the first power is 2. When you make it 2 to the negative 1 power, this is actually the plus-minus relationship in spherical space, that the positive numbers, 2 over 1, 4 over 1, now 3 is representable, but 1 over 3 is not. I think you know why. It's an infinite number, which means it's irrational, which means it's not representable, which means it's not computable. So 3 will not exist, because in the multiplicative system, every number has an inverse. Just as in the additive system of the line, +1 is balanced by -1 to the Archimedean, the center, the reference frame, the frame of reference, is 0, which is null in geometry. So that's a problem. When you switch to the multiplicative system, 1 is the central number, not 0, and you're looking at it. That is the surface of something. This pervades physics. That was discovered in the 20th century, and only in the 20th century was it discovered that this is the correct geometry that we need to be looking at. Otherwise, the radius is too small, and that's where we get the quantum limit. But it's the quantum limit in linear space. And that's why the Planck constant is very often represented as being divided in 2, that it's the Planck constant over 2. Really, what's being said there is a translation of the reduced Planck constant, which is, is drawn h bar. That is the Planck constant over tau. Now, tau is the value of this circle in radians. But we don't want that because it's irrational. It's 6.2813 ... which means it's incomputable. So we can't use it. The universe only uses computable number geometry, and our number system is incapable of measuring this circle because it's irrational. But if you convert to make the surface 1, all the numbers inside the circle are less than 1, correct? All the numbers outside the circle are greater than 1. That makes the surface, which is this circumference, the center of the geometric system. That's ultimately profound because of both what is inside the circle, which I think you can guess is the quantum. It's the quantum of action. It's the quantum of a lot of things. It's the quantum of space, the quantum of time, the quantum of energy, the quantum of motion. It's the quantum of everything is in this form. It cannot be discovered with extrinsic geometry. This is intrinsic geometry, the geometry of the object itself. Okay? So that's enough of that. You can see that centripetal force would be that circle being pulled in by a force. The surface would be being pulled in. That matches what we know of gravity. It has a center and it's spherical. That is well known. The centrifugal force would be that same force but invert, pushing out. That is EMR. Gravity is the opposite of light. But they're in 2 different domains, and that's the secret. You'll notice that I will say that's the secret a number of times. It's because this is a fish ladder paradox sequence. You have to solve all the steps to get to the solution, but that requires more orientation capability than science has at its disposal at this time. I have released that block. This is the correct center of the universe. You can say that because this does represent universal space. When this circle is translated to a sphere, it represents space. But as the circle itself, that would be the rotation equator of the sphere, correct? So that is the eigen of the sphere, is motion. And that's the other domain that we can't see. So inside the quantum limit, which if you measure it on the radius is inside this circle, you can't see the circle because it's bigger. And that's why we have 2 Planck units. We have a Planck unit that describes the radius, that is called h. We also have a Planck unit which is h over tau. It's h over 2 pi. That's the irrational number. That's the linear number that represents the circumference of a unit circle. So that's the relationship between 1 and what? It's the relationship between 1 and the circumference distance. But the circumference is not a distance. That's the secret. And I told you I would be saying that a number of times. That's a keen insight. The circle is what we can't see. That's why we use a wave function, because you have to linearize the circle into frequency and wavelength. There's another aspect to that that has to do with phase, but it's geometrically and mathematically linked to the wavelength frequency relationship. You may know, but it's worth saying now, that Max Planck discovered the lowest number in the universe. That was his discovery. It leads to a severe problem, which he was very unhappy with. He tried to deny his own discovery because he didn't like it. It was a piece of bubble gum, he thought. Well, that piece of bubble gum stuck. He discovered the lowest number in the universe. You know what it is? It's very hard to answer that question because it's a 2-component number. The smallest number in the universe is 2 numbers. They're 2 linear numbers. They're 2 dyadic fractions. The lowest number in the universe has to be divided into 2 numbers that represent 1, because the surface of this object is 1. What's inside is less than 1. What's outside is greater than 1. Wavelength is always less than 1. Frequency is always greater than 1. So the correct answer is in 2 forms, and you would get full credit if you gave both answers. What Max Planck discovered about our mathematical system, our number system, is the smallest number in the universe is 2, because it's the quantum of action. It's frequency. Frequency 2, there's nothing lower than that. So that is the index of spheric space. It's the jump from 1 to 2. The index in linear space is the jump from the center to the circumference. When that is measured linearly, the index of linear space is 1. Correct? Well, the jump is from 0 to 1. That's the linear quantum, h. In perfect relation with that is h over tau, and that's h bar. So those are the 2 quanta that you now see. The circular we'll say circular for now, but this is the sphere. This is actually the eigen of the sphere. It is a circle. The circle is the most natural object in the universe to our minds. The sphere is obviously a higher dimension circle, correct? That's extremely profound, which you just noticed. And that is a key, another key in the fish ladder sequence. So, the lowest number in the universe, to give the second answer, and you need both, the lowest linear number in the universe is 2. But that doesn't make sense because 1/2 is less than 2. Correct? All right, now you're starting to see the inside and the outside. And in between the inside and the outside is this circle. And what is on the circle are not points, but a redefinition of the point for the circle begins with 2. Correct? But this circle is 1. So this is the intersection of 2 domains. Yes, it is. The circle is the intersection of the outer domain, which we call space, and the inside, which we cannot call space. That is the quantum paradox restated. So what we can't see is inside the circle. What we can indirectly see on a relationship is what is on the circle. Think of that as the photon is that circle, and it's expanding. It's expanding at the speed of light, correct? That is the definition of the speed of light, is an expanding circle. That is in a lower dimension than spherical space. What happens on the circle of the sphere is called motion, and that is measured with points applied to the surface. What is the lowest number that can be applied to that surface? You might say 1, or you might say 2, but if you digested thoroughly what I said just before this, you know that it's 2. And that's the jump from the surface to the next sphere. That is a physical quantum jump. We have never been able to measure it. And now for the collapse of the wave function. That is a photon. It has a value of 1. That is light speed, because the frequency times the wavelength is always 1. Frequency, we'll just say 458. We know exactly what the wavelength is. It's 1 over 458. When you multiply those two reciprocal numbers together, you get the eigen of an expanding photon. Its spin. That's pure motion. You're looking at it. That circle is continuous. Therefore, it has a closure property for its mathematical parameterization. The circle is always 1, and so every number that represents the circle has to be 1. You can do that with multiplication. By multiplying two reciprocal numbers together, it is always light speed. Always light speed. The two components of the number, we think of it as distance over time, correct? Now we're talking about time. That's frequency, correct? Think about that a second. Is frequency spatial? You can linearize it, and that's what's done. The sine-cosine relationship will give you the two numbers for wavelength and frequency. But they always are light speed. They always are 1. So the two numbers multiply to 1. That's the definition of frequency. It's the whole number. It begins at 2, and we do not know the highest one. It's in the gamma range as we measure things. Very high frequency. That means a very large whole number. It's a whole number. And so frequency, will say the highest frequency is 1,000,000. We don't know what it is. Unless you accept the Planck length as this would be actually h bar. The reduced Planck length would be the measure of time. That is the index of the time domain. If you measure time, you can measure it by frequency. So the lowest time unit is 2 over 1. 2 of them. Okay? That would be frequency. This circle, which is the time, is the represent time is on this circle, but it's 2 numbers, and only one of them is time. That's frequency. The other one we call length. It's wave length. That's a contradiction. And that, if you would, is the solution to the collapse of the wave function geometrically. Is this circle is in 2 domains. It represents two domains that are intersected. This is the space domain, that's the wavelength, and the time domain, which is frequency. As you know, energy is defined as frequency. That is energy. So this is the relationship not between space and time. That's the linear derivative space and the linear derivative of this circle. This circle has two linear derivatives. One of them is frequency, the lowest of which, the Planck unit for frequency, is 2. It's the lowest number of action. That's motion. That represents time. So frequency, indeed, is time in direct relationship with space. And neither one of them is what we think it is, because they're together, and they can only be seen together. You're looking at it. And now I'm going to show you the secret of the universe that unlocks the unified field theory that Einstein sought, and no one has been able to achieve. The solution we seek is in the collapse of the wave function. This will explain it. I think you can tell it's explaining a lot more than that. So this is the energy circle called the eigen of the photon. The eigen of the photon represents the photon itself in terms of energy. You're looking at energy. It is the union of frequency and wavelength. So they're both on this circle. Put two dots. Look at B at the top and look at C at the bottom. It's in very small print, red, C. Those are two antipodal points. You could call it the North and South Pole. No, the poles are both aligned with the center. You're looking through a sphere. So you're looking into another dimension. It's actually a combination of two domains in spheric space, which could be called dimensions, but then it's confusing because linear dimensions are square. But spherical dimensions are circular. That's a major insight, of course. That's another key. Now for the collapse of the wave function. You have one point in two places. That's the lowest number in the universe for action, is 2. So you have 2 points that are at opposite ends of the circle. That's called the diameter, is the line that would intersect them, is the diameter. But that's not what we want. We just want those 2 points because we're only looking at the surface. We're not looking at what's inside or outside. We're looking at the surface, which is a third domain. If you consider in and out to be 2 domains, this is the one that's in between in and out. It's at the surface of in, going out, and it's at the surface of out, going in. That describes light and gravity and the proton and the electron in terms of two-force balanced mechanics according to Emmy Noether's Nobel Prize-winning discovery. I believe it was 1902. You can look that up. Emmy Noether is one of my heroes. I love women scientists of her caliber. It doesn't get any better than that. The two-force symmetry that explains universal mechanics as dynamics. You're also looking at dynamics. Now let's look at what's baffled the mechanists. When you have 2 points on the circle, that would be frequency 2. Where's the wavelength? I think you can see it. It's half of the circle. So the wavelength is now half to the proportion that the frequency is 2. Those are both dyadic fractions, 2 over 1 and 1 over 2. There is no way to trisect this, because 1 over 3 is an incomputable number, and therefore this is harmonic. That's been discovered at the protonic level. I just discovered it at the electronic level and photonic level. They're also harmonic. Harmonic means it's not linear in either of the 2 division quantities, numerator or denominator. There's no odd numbers. They're all actually powers of 2. and 1 is 2 to the 0th power. And that's the true position of 1. I should say, I'm sorry, it is the true position of 1 as well. In the dyadic number system, which our machines use, your computer is using dyadic fractions exclusively. Powers of 2. It can't represent 1 over 3. That's why you can't trisect the circle, because it's not harmonic. It jumps from 2 to 4, and from 4 to 8, in both directions simultaneously. So, when you have frequency 2 on the circle, it's the number of division points. And it represents exactly the wavelength, which you can see now is not precisely a length. It's also not precisely time. It's the relationship between space and energy. What you're looking at is non-spatial, because the circle itself is the relationship between space and energy. So energy is the circle. The two components of energy are time and the reciprocal of time. To the proportion that one of those numbers generates time, the other number generates space. And that's the geometric relationship that supersedes Albert Einstein's linearized solution. It's good for space travel, it works, but you need supercomputers, and therefore it's a monumental failure. It's not something that's exclusively for computers. This is for humans, so that we understand what the goddamn computers are actually computing. That's the purpose of science, is what I'm doing. So you have to have the solution to silence the pretenders. They're using the wrong mathematics, they're using the wrong number system, they're using the wrong visual system. This is correct. To the proportion that frequency is on this circle, it generates time. And to that proportion, the whole number, which is the number of points representing action, frequency, energy, is the generator of... That is the generator, since it's the whole number, frequency is the energy number, that's the photon. Its centrifugal force is 2. To the proportion that you could say the centripetal force is 1 over 2. And those two numbers are locked together. And that is the lowest number of all. It's 2 over 1 times 1 over 2. That equals light speed. This is the domain of light speed. You're looking at light speed. You're looking at energy. You're looking at the quantum. And here's how the collapse of the wave function works. That circle is the wave function. That is the wave function. And I believe you can now perceive directly that we cannot see that. It's perpendicular to our line of vision. We only see space. But this domain of energy is perpendicular to space, and we can't see that. But it does exist. But when this circle, which is a photon, it's a particle, reaches the telescope, there is nothing to collapse. It's traveling through another domain. That's why it's invisible. We can't see it. We can only see it when it arrives. But the way it arrives is through the domain of time. So there's nothing to collapse, because it's all the same event. It's the event that reaches your telescope. And that event is the eigen of light. That is energy. That is frequency. And so the wavelength is the imaginary realm. It's imaginary. That is why we use imaginary numbers. It's to gain some form of expression of the invisible, permanently invisible. We'll never see it. We can't see it because we're finite creatures. And I think that that is profound to the utmost degree, and that's 70 minutes. That's a lot. Thank you for tuning in. It's an honor. It only comes very infrequently in science, in physics, in mathematics, in geometry. This is an epical breakthrough that I have made. This is just the surface of a brand new universe that you can understand. I've just shown you how to see the imaginary realm that Paul Dirac could not, Albert Einstein could not, Richard Feynman never had a chance. Everyone since Feynman, luck just runs out, runs out. Because you have to see this, or you can't compute dynamics. This is Anagalactic, bringing you the secrets of the universe. I sincerely hope you enjoyed that. This is the 3rd day of December. I will now be continuing, now that I've delivered on my promise to show you the collapse of the wave function. That circle is in imaginary space. And so when it arrives through event space, and that is imaginary space, is event space. It's real. You know how we know it's real? It's imaginary. How do we know it's imaginary? Because it's real. And your center of consciousness is a point, but it's not a Euclidean point. It's a surface. And so God is within you. He's imaginary. That's why you can't take it. It's too imaginary for you. I think you may have food for thought. If you've never thought that way,